Now, the most common unit for expressing the quantity of gas in the air is a fraction of the total volume of air that the gas occupies. So it's a fraction. Um, that means it's dimensionless. And according to the ideal gas law, the volume at the same temperature pressure is proportional to the number of molecules. That means if you have more volume, then you have more number of molecules. And partial pressure exerted by a gas in a mixture of gases is proportional to the mole fraction. So um, if we know the partial pressure, we know the mole fraction. If we know the equation that relates the two, and if we know the mole fraction, we know the partial pressure, um, which relates to the same thing as the volume and its proportionality to the number of molecules. Because the more the mole fraction there is, the higher the mole fraction is, then the higher the partial pressure will be. So atmospheric gases, gases in the atmosphere can be considered as ideal gases. We can make that assumption. For example, carbon dioxide that occupies 0.04% of the volume of air, or more or less 400 ppm, means that the partial pressure of carbon dioxide in the air is about 0.04 fraction, or like I mentioned, 400 ppm out of 1 atm and 0.04 atm respectively.